So get your binder out. We're going to start notes first thing so I can get through as many as I can. The notes for today are going to be easy compared to what we have done the past couple days. Past couple days are doable. They just take a good chunk of time. So if you weren't here yesterday, we took notes over story problems. So the papers are here. Gavin. Why are we skipping so many? We're not skipping. You did it yesterday. What? You did this yesterday. No. So this gets the one you're on? Oh, yeah, I did. Yeah, I'm on the wrong one. Sorry. Anybody else need the note paper from yesterday? 63. Okay. So we are on page 62. So we did 61 yesterday on that. That's 60. That's 61. Okay, that's my mind. Okay, so 62. We are looking at 62 today. 61 we did yesterday. Guys, listen up, please. I don't have a ton of time. I want to get through as much as I can before I leave. So 61 we did yesterday. It was story problems. So I gave you a handout so you didn't have to write down the story problem. 62. We are looking at complex numbers. When I talk about a complex number, what I'm talking about is numbers that have real and imaginary parts. Now, real numbers are every number you've done up to this point. So any number you've done up to this point has been a real number. Decimals, fractions, negative, whatever, pi, those are all real numbers. Imaginary numbers, so complex, when I'm talking about a complex number, it has a real and an imaginary part. So for example, it might look something like this. 3 plus 2i. This is a complex number because it has two parts to it. So the real part is just the number that you've worked with up to this point. So basically, the part that does not have I is your real part. Your imaginary part is the part that has an I. And an imaginary number is just a different type of number. We'll talk about what it means in the next lesson. But an imaginary number is just a different type of number. We cannot graph it on a normal XY plane because it is imaginary. It's a different type of number. Okay? So if I'm plotting complex numbers on the plane, do not make this harder than it is. Even though it looks complicated because of the I, it has real and imaginary, you plot it like you would a normal XY plane. Except the only difference is your x-axis is your real axis, and your y-axis becomes your imaginary axis. Okay? So the difference is, instead of the x-axis, that becomes your real axis, and instead of the y-axis, that becomes your imaginary. So to graph this, we are graphing one point. Okay? To graph this, all you do is you say, well, my real part, what's the real part of this complex number? 3. So we're going to go right 3. Just like we would on a normal xy, if we were graphing a point, if your x value was 3, you'd go right 3. That's the same thing. So my real part is 3, and then my imaginary part is what? 2. So I'm going to go up 2 and put a point. That is it. So do not make this harder than it is. Even though these look weird, your real part is a positive 3, so you go right 3. Your imaginary part is a positive 2, so you go up 2 and put a point, and that's it.
Is the imaginary number always the one?
With I. Do what?
Is it always going to be an I?
Correct. Imaginary always will have the I. Yes. Okay, let's look at a couple more examples. What if... let's look at one. Wait just a second. Let's look at one like this. What if I have negative 3 minus 5i? Guys, pay attention, please. So negative 3 minus 5i. Okay? Real is your x-axis. Imaginary is your y-axis. And all you do is you graph it like you would a normal point. So my real part, the part without the I, is negative 3. So I'm going to go left 3. And then my imaginary is what? So you go down 5. So you go left 3, down 5. And that's your point. So you graph your real part and then your imaginary part. That's all you do. If you have one like this, let's say you have one like this. If I didn't have a real part, if I just had negative or if I just had like a 3i, positive 3i, I don't have any real part, so common sense would tell you.
It would only be an imagination.
Okay, so if I don't have any real part, I just have the number with the I, how would I graph it? You just go up 3. So if you would just have like, Andrea was asking, if you just had like a 4 and no I part, that's just a real number 4. So you would just go right 4. Okay? So don't make this, even though it's weird because you see I, just kind of graph it like you would normally. That's kind of going to be the theme for today. You're going to do it like normal. We're throwing in imaginary numbers, but you are going to do them basically the same way you do everything else you've done up to this point. Okay, let's look at 63. We are adding and subtracting complex numbers. So 63. Same theme. Do it the same way you have up to this point. So if I am adding or subtracting complex numbers. So let's look at this example. Let's say I have negative 8 plus 5i, and I'm adding that to 5 minus I. I am adding two complex numbers together. So negative 8 plus 5i is a complex number because it has real and imaginary. And then 5 minus I is also a complex number because I have a real part and an imaginary part. So I'm adding together two complex numbers. Use common sense. You treat it just like the x's or just like the i's were x's. So what two things can I combine together? The I. So what's 5i plus a negative 1i? 4i. You always put the imaginary part last, second. My real part would be negative 8 plus 5, which is negative 3. So you do it just like you would a normal polynomial, except now we have i's, but it's done the same way. Okay, what if I have one like this? 5 plus 6i minus 6i minus 5. So you go through and you basically combine like terms. You combine your real parts together. You combine your imaginary parts together. So if I combine my real parts, real always comes first. 5 minus 5, 0. And then 6i minus 6i is also just 0. You don't put 0i because that just is gone. So your answer is just 0.
Oh, so you just don't graph.
You go right in the point with a cross.
Because you wouldn't put 0. You don't put 0x. It just cancels out.
If there was one that equaled 0 on a graph, would you just put it right in the
Middle, yes.
Do you
Yeah.
have to graph them?
No.
When you're doing that?
No. You just add or subtract. Let's look at a subtraction one. What if I have 4 minus 6i minus 5 minus 4i? Okay, I am subtracting. I like distributing that negative through the second parenthesis. So negative 5 plus 4i. So whenever I'm subtracting two complex numbers like this, I like distributing that negative like we did with the normal polynomial. What's 4? Combine your real parts. 4 minus 5. And then what's negative 6i plus 4i? Negative 2i. The real part comes first. Imaginary comes second. That's it. Okay. Any questions on this? Want to do another one? Okay, let's do another subtraction. Let's look at this one. So negative 8 minus 3i minus negative 7 minus 6i. You don't have to necessarily distribute that negative. I like doing it so you know that you don't forget to use it. So negative 8 minus 3i. Distribute the negative will be plus 7 plus 6i. Yep, put your real parts together first. Negative 8 plus 7. Negative 1, your imaginary part, plus 3i, and that's it. So it's done the exact same way we've done before with polynomials. Okay, any questions on adding or subtracting? Okay, let's look at multiplying. We're going to do dividing tomorrow. We're going to look at multiplying today. Okay, you do it the same way. However, this is the thing that's going to be different. I squared is equal to negative 1. So, kind of a characteristic of I that we use is that I squared is equal to negative 1. So I is the square root of negative 1. Either way you write it. It's the same thing, because if I square both sides, I get I squared is equal to negative 1. So I is how we deal with being able to take the square root of a negative number. Because I've said up to this point, you can't take the square root of a negative, you get no solution. So I is introduced because that allows me to take the square root of a negative number. So I is equal to the square root of negative 1, and if I square both sides, I squared is equal to negative 1. So these are just kind of a couple definitions we're going to use. We're mostly going to use this I squared 1 when we multiply and divide. Okay? So anytime, the only difference, you're going to multiply, distribute, FOIL like normal. The only difference is if you get an I squared, you have to turn it into a negative 1. Okay? So if I look at one like this, let's look at this one. I have 2 plus 6i times negative 2 plus 3i. These are two complex numbers because you have a real and an imaginary part and then a real and an imaginary part. So common sense would tell you you're going to do what with this? FOIL it. Distributing, which foiling is a fancy type of distributing. You are going to FOIL it. We've done this a lot. So let's go ahead and FOIL. We did it yesterday actually. 2 times negative 2, negative 4. 2 times 3i, 2 times 3i, 6i. Huh? You can multiply. You can put them together. We can't add them together, but we can multiply. 6i times negative 2. And then 6i times 3i. 18i squared. You treat it just like a normal variable. You treat it just like x. Okay, now, as I look at this, just like we do with normal foiling, let's combine. What's 6i minus 12i? Okay, now here's the difference. The only thing that's different than normal foiling. Anytime you end up with an I squared, you have to plug in a negative 1 there. I squared is equal to negative 1. So anytime you end up with negative, or with an I squared, you plug in a negative 1.
Is there such a thing as a I to the inverse?
We're not going to, we'll deal with that maybe eventually, but we're not going to deal with it today. No, you're good. So I squared, anytime you get an I squared, make it a negative 1. So 18 times negative 1 makes it a negative 18. So I have negative 4 minus 6i minus 18.
I thought the eyes always came at the end.
Huh?
Oh, you said the
We will, just a second. What two things can I put together? Negative 4 minus 18.
So what the negative 1 goes away?
Negative 22 minus 6i. So, let me go through this again. Anytime you get an I squared, you plug a negative 1 in, and then you just multiply. 18 times negative 1 is negative 18, and then you can do negative 4 minus 18, which is negative 22. I want the I second. So your real part comes first, and then your imaginary part.
Alright. This all can kind of imaginary.
Well, that's okay. Okay, let's look at another example. Let's look at one. Okay, let's look at another one. Let's look at one like this. If I have negative 5i times 6i times negative 3 minus 2i. Okay, I'm multiplying three things together, so we're not going to FOIL necessarily. So let's just multiply. What's negative 5i times 6i? Negative 30i squared. So multiply those two together first. So that's negative 30i squared, and I still have negative 3 minus 2i. Now, like I just got done saying, anytime you end up with an I squared, that becomes a what? So negative 30 times negative 1, which is a positive 30, times that negative 3 minus 2i. Yeah, use distribute. 30 times negative 3, 30 times negative 2i, negative 60i. So like I said, do not make this stuff harder than it is. It's the same idea. The only difference is when you get an I squared, you plug in a negative 1. Okay. Any questions on that? Okay, let me look at one more example with you. Let's look at one like this. If I have Okay. Example 3. We're going to have, you might want to leave some space. We're going to have some to do tomorrow. So you may want to leave a little bit of space because we're going to do division tomorrow. Example 3, listen up. What if I have this? Negative 1 minus 4i squared. We've done one like these before. How do I treat this one? What does that mean? We're not trying to solve, so we're not trying to get rid of the square. What does squaring something mean? Timesing it by itself. So you can't just distribute the 2 because it's an exponent. So you need to write, when you are squaring a binomial, squaring a binomial literally means multiplying it by itself. That's what squaring something means. So I would rewrite this as negative 1 minus 4i times negative 1 minus 4i. Now you notice that I can do what? FOIL, or fancy distributing. So take your first two terms, negative 1 times negative 1, 1. Negative 1 times negative 4i, positive 4i. My middle 2, negative 4i times negative 1, plus 4i. And then my last 2, negative 4i times negative 4i, 16i squared. So you do it like a normal polynomial we've done before. Now here's the part that's different. Okay? So first of all, 4i plus 4i, 8i. I squared gets replaced with negative 1. So it becomes 16 times negative 1. 16 times negative 1, negative 16. 1 minus 16, negative 15, plus 8i. Okay? Any questions on multiplying?
Isn't division?
Hurry up.